Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to solve the third numerical which is based on ideal gas equation, and this question is basically different, so let us solve it. So friends, this is a question which is based on the ideal gas equation. So let us understand the question, that what are they trying to say. So they have said that we have to calculate the volume in liter occupied by 7.40 gram of ammonia at STP, and they have also provided the molar mass of ammonia, that is NH3 is equals to 17 gram per mole. So they have provided us a few datas, and from there and from which we have to calculate what would be the volume of that particular gas, or for that particular ammonia at STP. So now let us do, and let us solve this thing by first extracting the data from the given question. So the given data has, first of all, they have given us the weight of the ammonia. So therefore I would write it as W, that is, which denotes the weight, which is 7.40 gram of ammonia, that is basically of NH3. As well as they have also provided the molecular weight, that is, I am denoting it by M as 17 gram per mole. As well as they have mentioned that we have to calculate the volume, and in this case they have provided us STP. STP means standard temperature pressure condition. So therefore at STP, basically I would write it here so that it would be very much easy to understand that why at STP we take the value of pressure and temperature. That is basically, when I'm talking about temperature, it is basically 273.15. This is nothing but the standard temperature. Okay, when I'm talking about the pressure, now the pressure would be basically 1 atmosphere. So this is the thing that where we have calculated, or we have assumed that the pressure would be 1 atmosphere. So suppose if the pressure is being 1 atmosphere and everything has been provided to us, and we have to calculate the V, but one thing has been missing, that is the value of R, and this plays a very important role, that what will be the value of R. In the previous lecture also we have did there are 4 values of R with of different units. So among 4, what we are going to substitute, or what we are going to use. So the first condition is, they have asked us to calculate the volume in liters, and we know that during we have taken the lecture of the gas constant, and in the first thing that we have mentioned the value of R in liter atmosphere per Kelvin per mole. So the pressure is being present in atmosphere, that is at STP, and we have to calculate the value, or value of the volume in liters. So basically the value of R is nothing but 0.082 liter atmosphere per Kelvin per mole. So this is the value. So this plays a very important, that is what I was trying to say in that lecture also. This plays a very important role, and now it would be very much easy to solve the numerical. So because this is based on the ideal gas equation, as well as we could predict that suppose if you don't know whether this numerical is belonging to which equation, so you could easily predict that the pressure, the temperature, the volume, and the gas constant, that is R, is being mentioned. So basically they are talking about the ideal gas equation itself. So therefore, moving further, so as you know that according to ideal gas equation, we know PV is equals to nRT, but P into V, where when I'm talking about the number of moles is nothing but weight divided by molecular weight into R into T. So in this case, what we have to calculate, the value of V. So therefore V is equals to W into R into T, the whole divided by molecular weight into pressure. So this is the formula that we have to use, and we have to substitute the values here. So what I'll try to do is, I'm writing it here again, so it would be in a very flow way. So therefore W into R into T, the whole divided by basically molecular weight into pressure. So the weight that they have given to us for that we have written in our data, which was found to be basically 7.40 into the value of R that we have assumed, or we have made the gas constant. We have calculated again earlier also, and from that we have got the value of R as 0.082, that is liter atmosphere per Kelvin per mole. And talking about the temperature, and because they are stating that it has been the standard temperature and pressure, so for standard temperature we have basically 273.15 Kelvin, and the molecular weight of the ammonia that is being given as 17, while that of the pressure, which is nothing but 1 atmosphere. So if I calculate this thing, let us see what is the answer that we could get. So we have got the answer as 9.74 liter. And the value that we have got, that is 9.74, and it has been having a unit of liter because we have used the value of R, which has a unit in liter atmosphere per mole per Kelvin. So that makes us and we don't have to convert in anyway. So suppose if we have got the value, this value would be in liter, this value won't be in dm cube or something else, because that's only what I'm trying to say, that the value of R is basically more important while calculating or while using in ideal gas equation. So thank you friends for watching this video. I hope you have liked this video, and yes, you will share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.